Hello students, welcome to another lesson for this week, which is writing rational exponents to radicals and vice versa. The goal of the lesson is to write expressions with rational exponents to radicals and vice versa. Before we proceed to our main lesson, let us discuss some important terms related to radical expression. A radical expression is defined as any expression containing a radical symbol. Next, the parts of a radical expression. In any radical expression, b the nth root of a, b stands for the coefficient of the radical. Next, this is the symbol for the radical sign. Then n stands for the index. It is the number of the root to be taken. Then a, it is the radicand, the quantity to take the root of. In writing rational exponents to radicals and vice versa, a rational exponent represented by a raised to m over n, the base of the rational exponents a will serve as the radicand of the radical expression. In the rational number m over n, the denominator n will serve as the index of the radical expression, while the numerator m will serve as the exponent of the radicand. Now, let us write the following to radical expressions. Number 1, 3 raised to 1/2. In the rational exponent 1/2, the denominator 2 will serve as our index of the radical expression, while the numerator 1 will serve as the exponent of the radicand, which is 3. So that is equal to the square root of 3. If there is no number written in the index of the radical expressions, it is understood that the index is 2, and it is read as square root, like this example. So that is square root of 3. Next, number 2, x raised to 2 over 3. Take note that our denominator 3 will serve as the index, and the numerator 2 will serve as the exponent of the radicand, which is x. So that is equal to the cube root of x squared. Next, number 3, 2 raised to negative 2 over 5. This is equal to the fifth root of 2 raised to negative 2. Here, we have the negative exponent of the radicand 2. So we need to follow the rule for negative exponent, so that will become the fifth root of 1 over 2 raised to 2. Number 4, 5x raised to 1/4. Notice that only the variable x has the rational exponents of 1/4, meaning to say it is the only expression written inside the radical sign, then 5 is written outside the radical sign. Therefore, the answer is 5, the fourth root of x. Number 5, quantity 7y raised to 2 over 7. It is written as the seventh root of the quantity 7y raised to 2. Then distribute the exponent of 2 to the radicand 7y. So the final answer is the seventh root of 7 squared y squared. Last, quantity 4m raised to negative 3 over 4. It is written as the fourth root of the quantity 4m raised to negative 3. Following the rule of negative exponents, the final answer will become the fourth root of 1 over 4 raised to 3 m raised to 3. Now, let us reverse the process. Let us write the following to rational exponents. Number 1, the square root of 7. To change this to rational exponents, 7 will be the base. The exponent of 7, which is 1, will be the numerator. Then the index, which is 2, will serve as the denominator of a rational exponent. So that is equal to 7 raised to 1/2. Number 2, the cube root of m raised to 5. It is written as m raised to 5 over 3. The numerator will be the exponent of m, and then the denominator of 3, which is the index of the radical expression. Number 3, the fourth root of 1 over 3 raised to 3. This is a negative rational exponents. So therefore, it is written as 3 raised to negative 3 over 4. Number 4, 2x, the fifth root of y raised to 2. Here, only the radicand y has the rational exponents because that is the only expression written inside the radical sign. So meaning to say 2x does not have the rational exponent. So that is equal to 2x y raised to 2 over 5. Number 5, 6th root of the quantity 5ab raised to 5. That is equal to the quantity 5ab raised to 5 over 6. This is also equal to the quantity 5 raised to 5, a raised to 5, b raised to 5, raised to 1 over 6. Number 6, 7th root of 1 over the quantity 3y raised to 2. This is the same with number 3. This is a negative rational exponent. So that is equal to the quantity 3y raised to negative 2 over 7.